In calculus, we need to be able to interpret graphs, and probably the most important thing, at least at the beginning, is to make sure you understand what type of graph you've been given. Is it a graph of an original function? Is it the graph of a derivative, first derivative, or is it the graph of a second derivative? Because it completely changes how you interpret things based on what type of graph it is. So I'm looking at problem number 6, and this is problem number 6 from the worksheet that you're being assigned. We'll just go ahead and walk our way through this one together, and then you can do the rest of the problems. So first thing I'm noticing here is that this is the graph of a derivative. Okay, and so now for myself, and I like to go ahead and do a number line graph because I think it just really locks things in a lot better for myself. And you don't necessarily have to do this, but I think it's if you're struggling with it at all, I think it's a very good idea. So f prime number line. Okay, now first off, since it's a derivative graph, I'm looking for, is there any place where the derivative is equal to 0 or does not exist? Now, as far as does not exist, now this one goes forever left and right, and there's no discontinuities along the way or anything like that. But it is equal to 0 at, looks like -2, and also looks like +4. So -2 and +4, and that's where the derivative is equal to 0. Okay, now where the graph is above the x-axis, that's where the derivative is positive, and where the graph is below the x-axis, that's where the derivative is negative, because this is the graph of the derivative. And so it's out here to the left of -2, it's below the x-axis, so those are negative y values, and out to the right of 4, it's below the x-axis, so those are negative values for the derivative. And in between, it's above that whole time, so those are positive y values. So what does that tell us about the function f? Well, where the derivative is negative, it's decreasing. And where the function is, where the derivative is positive, that's where the function is increasing. And so negative, positive, so this is a relative min at -2, and we have a relative max at 4. And so we can actually write down all this kind of stuff. So f is increasing on the open interval from -3 to 4. It's decreasing from -infinity to -2 union 4 to infinity. Okay, and there's a relative minimum at x equals -2, relative maximum at x equals 4. Okay, now concavity, concave up, concave down, points of inflection. Now, how does that's second derivative stuff. So how does second derivative stuff relate to the graph that we're given? We've been given the graph of a derivative, and so second derivative stuff is the derivative of this graph. And what are we doing when we're doing derivatives? We're doing slopes of tangent lines. Okay, so since I'm now looking at the next derivative, which is the second derivative overall. So is there any place where the second derivative is 0? Yeah, so here at -1/2, here at +3/2, and here at +3. And otherwise, it's a nice smooth curve, so the second derivative seems to be existing everywhere else, but we do have 3 places where it's equal to 0. So approximately -1/2, approximately 3/2, and they're at 3 also. And then as far as slopes of tangent lines, so we got positive tangent slopes to the left of -1/2, and negative between -1/2 and 3/2, and then positive again between 3/2 and 3, and then negative out here to the right of 3. And so what is that telling me about my function f? Well, it's concave up wherever the second derivative is positive, and it's concave down wherever the second derivative is negative. And Points of inflection are where the second derivative has a change of signs or a change of concavity. So negative 1/2, 3/2, and 3 are all points of inflection. So negative 1/2, 3/2, and 3, those are all points of inflection. And it's concave up from negative infinity to negative 1/2 union 3/2 to 3, and it's concave down from negative 1/2 to 3/2, and then also from 3 to infinity. Okay, so go ahead and work on the rest of this worksheet to have it done for the next class.